Alright, let's go ahead and refresh the concepts of solving inequalities. Let's go and solving. Let's extend the concepts of equation solving to solving inequalities. And again, what that is basically the four comparison symbols we have in mathematics, right? So greater than, less than, greater than or equal to, less than or equal to. These four comparison symbols, right? Solving inequalities. And the way we solve inequalities is basically the same way we solve equations. So for example, if I give you something like this, such as 2x plus 6. 2x plus 6 is less than or equal to, let's say, 5x plus 27. Alright, let's go and solve this, and let's write the answer in, for example, in set builder or interval notation. We'll do in both notations to give you a feel for it. But in the homework, you'll get to practice with both, obviously, and graph it as well. Alright. Anyways, treat this like an equation. Treat this as if you're solving 2x plus 6 equal to 5x plus 27. Now, what I would do though is for inequalities, it's easier to interpret or read a solution if you get the x's on the left side and numbers on the right side. Now, for equations, it didn't matter which side you got the x or the numbers, if you will. Excuse me. But for inequalities, it's probably better to get the x terms on the left, numbers on the right. So I'm going to do that. So let me go ahead and subtract 5x on both sides to do that, obviously. So we'll minus the 5x on both sides. Alright, so that takes care of that. So we're going to get negative 3x plus 6 is less than or equal to 27. Alright, so pretty straightforward so far. Then obviously get numbers on the right by subtracting 6 on both sides. So we've seen that in the past. Right? So again, just like an equation, right? So negative 3x is less than or equal to what? 21. All right? Not too bad. Now, the only exception here with inequalities is that when you multiply or divide by a negative number, right? So let's recall that concept. Here I have to finish solving for x, I need to what? Divide both sides by negative 3. All right? But when I do that, so I'm dividing both sides by a negative number, I have to do what? Well, we have to what? Switch the direction of this inequality. So we're going to get x instead of less than or equal to, that becomes greater than or equal to. All right. So again, when you multiply or divide by a negative number, you're going to switch the direction of the inequality. In this case, 21 over negative 3 is going to be what? Negative 7. So our solution here is going to be x greater than or equal to negative 7. Right. So let me go ahead and refresh you on that concept again. So let me say switch the direction of the inequality, inequality when multiplying, in this case dividing here, when multiplying or dividing by a negative number. So key concept to keep in mind to refresh yourself on, right? So again, anytime you're dividing both sides by a negative number or multiplying both sides by a negative number, you have to what? Switch the direction of the inequality. In this case, from less than or equal to what? Greater than or equal to. All right? Now, quickly, let's write that in set builder notation. So let's look at set builder. We've seen that from earlier, right? So set builder notation says what then? This would be what? Solutions all real numbers bigger than or equal to what? Negative 7. So all real numbers x such that x is greater than or equal to negative 7. All right, no big deal. Let's look at interval notation. Then that will be what? From negative 7 on to infinity. So it's including equal sign, including negative 7. So it's going to be what? Bracket at negative 7. 7 there, sorry about that, on to positive infinity. Alright? So again, know how to write the solution in both notations. Now, if we're to graph this, then real quickly, let's refresh ourselves on that as well. So let's say here's negative 7 on the number line. Of course, 0 is on the right. Negative 10 is on the left, for example, right? But again, what goes on negative 7 since we're including it? Well, again, the bracket, right? So bracket on negative 7, arrow to the right. Okay, so no big deal. But again, the key concept I want you to refresh here is what? When you're dividing both sides by a negative number, then just simply switch the direction of the inequality. All right, so let's recall that concept. But again, the rest is the same as equation solving, right? So x is on one side, preferably the left side for inequalities, and numbers on the right side. Okay, let's go and try another one. let's go and try another one. Let me go and clear out the screen. Let's go and try this one. Let's go and solve, and again, same thing, write in both notations as well as graph it. All right. So let's go ahead and solve this one here. 5x plus 8. 5x plus 8 less than. Let's say less than 4. 4 plus 3 times the quantity x minus 2. All right, let's look at this inequality again. Again, treat it like an equation, right? So let's simplify the right side and get x's on the left, numbers on the right. So let's do that. So 5x plus 8 stays the same here. Let me now don't add the 4 and 3, right? Because that'll be violating the order of operations. We need to distribute the 3 here instead, right? So 3 times x is 3x. All right, and 3 times negative 2 is going to be what? Negative 6. That's a 3 right there. Sorry about that. All right, so make sure we see that combined like terms. So 5x plus 8 stays the same again, less than what? 3x. 4 minus 6 minus 2, negative 2. All right, so again, let's get x's on the left, numbers on the right. So let me combine that in one step if you don't mind. So I'm going to subtract 3x to get the x's on the left side. All right, that takes care of that. Let me subtract 8 on both sides if you don't mind to get the numbers on the right. So we're going to get 2x is less than what? Negative 10. All right, so now divide both sides by 2, but do I switch the inequality? Well, in this case, I do not. Can we see that? Because I'm not, even though I have negative 10 here, I'm not dividing both sides by a negative number. I'm dividing both sides by a positive number. So I do not touch this inequality. I do not switch it. So it stays the same. So final solution will be what? X less than what? Negative 5. That's our solution. All right? So again, do not switch to inequality if you're dividing by a positive number. Even though this is negative, that's fine. But we only switch when we divide or multiply both sides by what? A negative number. In this case, we didn't do that. All right, so be careful here. But anyways, there's our solution again. Let's look at real quickly set builder notation again, right? So that's going to be all real numbers x, such that x is what? Less than negative 5. No big deal there. All real numbers less than negative 5. Interval notation, then it'll be what? From negative infinity up to negative 5, but not including, right? So it's going to be negative infinity, comma what? Negative 5, but not including it, so parentheses on negative 5, not bracket. Right. So again, make sure we're comfortable with the both notations, set builder and interval notation here to express our solution. And to graph this, then again, not too hard on that. Here's negative 5 again. Everything less than that, so less than, right? So parentheses on it, arrow to the what? To the left. Okay, so make sure we can graph it as well. But hopefully that's review material for us, right? The key is what? Be able to solve these inequalities. Again, just treat these like equations and get x on the left, numbers on the right. Okay, let's go and try one more now. I want to take a look at what's called compound inequalities. Let me go and clear out the screen. Let's take a look at this inequality here then. So 6, let's go and solve 6 times 1 minus x, all right, is less than or equal to 26 minus 2 times the quantity x minus 2. All right, let's go ahead and again simplify. Treat this like an equation again. Simplify the right-hand side in this case. And the left side, let me distribute the 6 then, obviously. So 6 times 1 is 6. 6 times negative x, negative 6x. Can we see that? Less than or equal to. Again, don't subtract 26 and 2. Again, we need to bring the 26 down and distribute this as a negative 2. So we're going to get what? Negative 2x and positive what? 4, right? Negative 2 and negative 2 plus 4. All right, so we're going to get 6 minus 6x less than or equal to. Combine like terms here, so negative 2x, 26 plus 4 is what? 30. Okay, so that's a 0 there, sorry about that. All right, anyways, let's get x again on the left side, numbers on the right side. So I'm going to add 2x over to the left-hand side and move the x term to the left side here. Let me subtract 6 at the same time, if you don't mind, to gather the numbers on the right side. So we're going to get what? Negative 4x, all right, less than or equal to what? Positive 24 in that case, right? 30 minus 6. All right, now this time I do have to divide by negative 4 on both sides. So I am dividing by a negative number, so therefore I do have to what? Switch that direction around. So change the direction of that inequality from from less than or equal to greater than or equal to, in this case 26 over negative 4, negative 6. So our solution will be what? X greater than or equal to negative 6. Again, x greater than or equal to negative 6. All right, again, set builder notation on that. All real numbers x, such that x is greater than or equal to -6, no big deal there. And interval notation is what? This time we are including the -6, right? So it's going to be bracket on -6 onto what? Onto infinity. All right. So again, know both notations. Obviously, be able to graph it as well, but we're not going to spend any more time on that. All right. Anyways, let's make sure we know how to solve these inequalities. Again, one exception is what? Dividing both sides by a negative number or multiplying both sides by a negative number. Make sure you switch the direction of the inequality when you do that. All right. All right. Let's go ahead and take a look at compound inequalities. I'm going to go and clear out the screen. Now, basically, compound inequalities are just inequalities that are combined using the words and or. So let's look at some examples of compound inequalities. Examples of what's called compound inequalities. All we're doing here is just combining two inequalities together with the words and or. So, for example, let's say we have something like x less than -2 or x greater than or equal to +2, right? So that means what? The word or, that means what? Union. Think union of two sets, right? Either we're less than -2 or we're what? Bigger than or equal to 2, right? So think of this word or as union. All right? So in other words, if you were to express this compound inequality in interval notation, so interval notation, then you would use the union symbol, right? Because it would be what? It's going to be everything less than -2, so what? Negative infinity up to -2, but not including it, right? So parentheses there. And union with what? 2 or bigger. So bracket on 2 to infinity. All right? So be comfortable with the symbol union, and or again means union. All right? We're combining these two sets using these two inequalities using the word or. All right. Now, what about the word and? Let's go and try that one. Let's take a look at. Take a look at this one. How about x greater than let's keep it along these lines. X greater than what? -2, or x less than or equal to +2. Not or. Sorry about that. Make it and. Apologize for that. All right. Again, and though means what? We have to satisfy both of these inequalities. So think of this as the intersection of two sets. So intersection of two sets, because we have to be both bigger than -2 and at the same time be less than or equal to +2. Well, what are some numbers that will satisfy this? Well, what about the number 0? Because 0 is bigger than -2 and it's also less than +2. What about the number 1? Same thing. It satisfies this intersection, the combination of these two sets. All right. So how do we write that in interval notation? Well, because this and inequality is basically saying, if you interpret this correctly, it's saying what? All the real numbers that are bigger than -2 and less than or equal to +2, but that's the same as saying that all real numbers between these two numbers, right? Less than x, less than or equal to 2. So this is the interpretation there, right? So we can interpret the intersection with this what's called a double inequality here, right? This is called a double inequality. We'll talk about solving this in a moment here, right? But again, let's go ahead and take a look at the interval notation on this guy, right? So well then, interval notation will be what? Everything between -2 and 2, but including the 2, right? So interval notation. Oops. Interval notation, parentheses on -2, comma what? 2, and we are including the 2, so bracket on it. All right? And again, but for set builder, again, if you need to write that in set builder, not too bad at all. Just put that in there, right? So put this double inequality in there. For set builder, it will be what? Set of all real numbers x such that -2 is less than x, less than or equal to +2. All right, that's set builder notation. All right. So, anyways, so nothing new really too much, right? Compound inequality is just what? Using the words or, which means union, or and, which means intersection, to join two inequalities together. All right. Now, how do we solve compound inequalities? Well, as you may suspect, we simply solve each of them separately and then put them together. So here's what I mean by that. Let's go and take a look at this problem. Let me go and clear out the screen. All right, let's go and solve the following compound inequality. All right, let's go and solve something such as let me see here if I have something for you here. Yeah, such as something like 2. So let's solve 2. Let me see here. Alright, sorry about that, guys. So 2 minus 3x. We have 2 minus 3x greater than 11. Keyword is word or. Alright, or what? 5 plus 2x. 5 plus 2x is greater than 7. Alright, so 2 minus 3x greater than 11, or 5 plus 2x greater than 7. Alright, so let's go ahead and solve these things separately. Well, that's not too hard. Just subtract 2 on both sides. Here, obviously, takes care of that. So negative 3x is greater than what? 11 minus 2 is going to be 9, right? So then divide both sides by negative 3 again, dividing by a negative number. So we do have to switch this inequality to less than 9 over negative 3 is negative 3. So there's the first solution. My second one, subtract 5 on both sides. Again, just solve each of them separately is the theme here, right? For compound inequalities. 2x greater than 2 or x greater than 1 if we divide both sides by 2 here. And this time we don't switch because we're dividing by a positive number in this case, right? But the key words were what? Or that joins them, right? So either we're less than negative 3 or we're what? Bigger than 1. Again, how do we write that in set builder notation, for example? Then let's just do both. Let's do both interval and set builder. So for set builder, it will be what? Set of all real numbers x such that x is what? Less than negative 3 or x is bigger than 1. Alright? Does that make sense? Can we see that? Now, let's go ahead and write that in interval notation. So here's set builder. Let's look at interval. That's going to be what? From negative infinity up to negative 3. So negative infinity up to negative 3, not including it, so parentheses on it. And the or means what? Union, right? So union of what? Again, not including 1, so 1 in parentheses to positive infinity. Alright, so this is the what? Interval notation of this solution here. But again, all we're doing is what? Solving them separately and then putting the solutions together in terms of a union or set builder notation using the word or. Anyways, let's suppose I change this word up here from or to and. Would that have made sense? Well, if I change the word or to and, let's go back to so if I change this word to and, right? So I would have what? X less than negative 3 and, right? X greater than 1. Well, this makes no sense because how can you be less than negative 3 and at the same time be bigger than 1? That's impossible. So if you get something like this, then obviously there's no solution, right? Impossible or no solution, and we say what? Empty set. Or empty set in that case. So again, only the word or makes sense here. The word and would not have made sense, right? Because again, we cannot be less than negative 3 and at the same time be bigger than 1. We can be less than negative 3 or be bigger than 1, but not both, right? So either we're here or we're here, but we can't be in both places in this case, right? So no solution if it's and, but there is a solution in this case if it's or. Okay, let's go and take a look at this problem then. I'm going to clear out the screen here. All right, let's go and try this one. Let's take a look at something like 5 minus 4x greater than 1. 5 minus 4x is greater than 1. Keywords times and. Alright, let's see if there's going to be a solution here. Or the empty set maybe. 6 minus 5x is less than 11. Alright, so again, to solve compound inequality, what do? You just simply solve them separately. So let's go and do that. Let's go subtract 5 on both sides. No big deal there. So negative 4x is greater than what? Negative 4. But again, I do have to divide by a negative number, so I do have to switch to inequality here. So x will be what? Less than what? Less than negative 1. Alright? So there's the first solution. Alright? And again, keyword to join these two solutions will be with the word and this time, right? So subtract 6 on both sides. So we get negative 5x is going to be what? Less than 5. So divide by negative 5. Again, we need to switch the direction of the inequality because we're divided by a negative number. So x will be what? Greater than negative 1. Alright? Keywords were what? And. that joins these together. So are there numbers that satisfies this? Do we have numbers that are less than -1 and at the same time greater than -1? All right. Anyways, yeah, looks like I kind of screwed up here. Sorry, guys. Right here, guys. Right, so that's -4. This is positive, right? So this should have been +1. So let me cross that out. Should have been x less than what? +1. +1. Sorry about that. Little bit error there on my part, right? So I apologize for that. So yeah, there, that's a lot better now. So can we be less than 1 and greater than -1? Yes, we can. So there's a solution this time, right? There is a solution here. So again, apologize for the mistake up here. Negative by negative is +1. Okay, so hopefully you saw that before I corrected it. So I apologize again. But anyways, yeah. For example, what? For example, 0 again, right? 0 is certainly bigger than -1. It's certainly less than 1. So there are numbers in here. Basically, this is saying all real numbers between what? -1 and 1. So in other words, the interpretation here is going to be this double inequality. -1 less than x, which is less than 1. All numbers between -1 and 1 will work, right? Because the word and, the intersection, not union, right? Intersection of these two sets, joining these two sets together. All right? So in that case, if we were to write that in set builder notation, it would be all real numbers x, such that this double inequality, -1 less than x, which is less than 1. All right? In interval notation, it's just parentheses -1, comma 1 in parentheses. Then there's no equal sign here to include the endpoints, just parentheses then. Right? So again, apologize for the mistake here again, but hopefully you can see the solution where you just solve each separately and put them together. So be a little bit more careful with the AND situation. All right, let's go ahead and take a look at solving double inequalities to finish out then, guys. Right, the key there for solving double inequalities is to simply operate on both ends of it. So here's what I mean by that. Let's go and clear out the screen. Let me do an example for you. All right, so take a look at this problem right here. Take a look at something like -1, -1 less than, let's say 2x plus 5, which is less than 9. All right, make it less than or equal to 9. Doesn't matter. Make it equal in this case, right? All right. Anyways, to solve this, you can break it up into two separate ones because this is basically saying what? -1 is less than 2x plus 5, and keyword is and, right, for double inequality, right? And 2x plus 5 is less than or equal to 9. Solve them separately and put them back together. But there's no need to do it this way. For double inequalities of this type, you simply operate on both ends. So here's what I mean by it. Let me go and copy the problem again. -1 less than 2x plus 5 less than or equal to 9. Operate on both ends means what? Get the x by itself in the middle here. Now to do that, what needs to happen? Well, we need to subtract the 5 out. When you subtract the 5 out, you're going to subtract the 5 out on both ends, on the left end and on the right end. It's sort of like subtracting 5 here, subtracting 5 here. You can see you can mirror the two operations here, right? If you break it up separately. But again, my point is you don't have to do that. You simply solve it all together and operate on each end of the double inequality. So then you're going to get 5's dropping off. You get what? -6 on the left end, less than 2x, which is less than or equal to what? +4 on the right end. Now divide out the 2 again, do it to both ends. All right. So you're going to get what? -3 less than x less than or equal to 2 as the solution. In other words, all real numbers between -3 and 2, including 2, will be solutions. All right. And to write that in set builder notation, or I'm sorry, let's just make it interval notation. We can certainly do both notations, but I'll just do interval here. It's going to be what? Parentheses -3, since we're not including it, comma 2. This time we are including 2. Bracket. All right. So hopefully not too bad at all in terms of solving double inequality. Just operate on both ends here, right? Let me go and squeeze one more in here, if you don't mind, here on this small space that's left here. Let's go and try this one. How about -2 less than or equal to 5x plus 3 less than or equal to 13. All right. So again, operate on both ends. Subtract 3 out on both ends. No big deal. Cancels out. Get -5 there, less than or equal to 5x in the middle. less than or equal to what? 13 minus 3, 10. Alright? And divide both ends by what? By 5 to finish. Alright, so no big deal, as you can see, right? So pretty easy to solve double inequalities. Just operate on both ends is really the bottom line here, right? So you get negative 1 less than or equal to x, which is less than or equal to 2. So all real numbers between negative 1 and 2, including these endpoints, will be solutions. So in interval notation again, it'll be bracket negative 1, comma 2, bracket as well. Alright, so again, solving compound inequalities as well as double inequalities, not difficult at all, as you can see. Alright, let's go and finish out with some problems for you to do on Blackboard in terms of posting them, and just use set builder notation here. So let me go and clear out the screen. Let's go and try these problems on Blackboard here. Let's go and solve each of these. Right, so solve, for example, solve the first one here. How about 2 minus 5 times the quantity x plus 1 is going to be greater than 3 times x minus 1, 3 times quantity x minus 1, minus 8. Okay, so just again get x on the left, numbers on the right, and write the solution in set builder notation. So let's just go and write the solution in Blackboard. Use set builder notation for the solution. Set builder notation. So use that for all three problems I'm going to give you right here. So use this notation. All right. Let's go on look number 2. Solve the following here. How about 6x minus 2? 6x minus 2 is less than negative 14, or, keyword being or, 5x plus 1. 5x plus 1 greater than 11. Alright, greater than 11. So 6x minus 2 less than negative 14, or, keyword being or here, 5x plus 1 greater than 11. So think of this as a union of two sets, right? But again, just write the solution in what set builder notation here. This is greater than, there's no equal sign here. Sorry for the scribble here. No equal sign. Just standard greater than, guys. No equal sign, alright? Alright, number 3. Let's go and solve the following double inequality. Let me give you a double inequality solve here. On number 3 here, how about 5? Again, less than 4x minus 3, which is less than 21. So 5 less than 4x minus 3 less than 21. Operate on both ends and post the solution into Blackboard, again using set builder notation for all three problems. Alright, so give it a shot. We'll go over it in class then. Until next time.